Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem aggressive cows. So the problem statement says that we are given an array with unique elements of stalls which denote the position of stalls. You are also given an integer k which denotes the number of aggressive cows, and the task is to assign stalls to k cows such that the minimum distance between any two of them is the maximum possible. So this is very simple. We can see that in the input we are just given this stalls where the ith element represent the position of the stall, and k is the number of cows, and those cows are aggressive. So we have to place cows to we have to place k cows into those n stalls, let's say, such that the minimum distance between any two cows should be the maximum possible. So now we have to just return that possible answer, the minimum distance between any two of them, which is the maximum possible. We have to return that distance. So now in the example 1, I am taking the example 1 only. So here we can see stalls are given 1, 2, 4, 8 and 9, and 3 cows are there from the example 1. Now how we can solve this problem? So see, this problem is like finding max of min, and we already know that if problem says about finding the max of min or min of max, we can just apply binary search. So we can think here of what is the minimum possible answer. Just think that what is the minimum possible answer here. So, but before before finding the minimum possible and maximum possible answer, I would just say that let's try to find out the answer of this example. So we can see that from the example one, the first cow can be placed at stalls of 0. Let's say the position of those stalls are this 1, this 2, 4 is something here, and then 8 is something here, and 9 is here. So now we have to place 3 cows. How we will just place such that the minimum distance between two cows is the maximum. So we have 3 cows. We can place one cow here, and we can place one cow here, two opposite directions, and one cow we can place in the mid between. So now the minimum distance between two of them, here we can see it is coming 3, and here we can see it is coming 5. So the minimum distance is 3, and this is the only possible, because if we try to place the third cow here, then the minimum distance will be 1, and if we try to place here, the minimum distance will be 1. So if I make these arrangements, we can see the minimum distance between two cows is just 3. So this is the possible answer. Now we can find it through binary search also. We just have to uh, think about the minimum possible answer. So what is the minimum possible answer? Minimum possible answer. Minimum possible answer or distance we just call. So what is the minimum possible distance? So I'm assuming this array is sorted. If this array will not be sorted, we can just sort this array. So what is the minimum possible distance between any two cows? So let's say there were only two stalls. So the minimum distance will be what? The distance between those two stalls. So we can just check the adjacent distances among them, and we can just check the adjacent distance between any two stalls after sorting them, and the minimum distance can be our minimum possible distance. But for the simplicity, for the simplicity, we can just take it as 1 also. There will be no problem. And what is the maximum possible distance? What is the maximum possible distance? The maximum possible distance can be what? That we place, let's say, two cows are there, and we can place those two cows at the farthest stalls, farthest distance, that is to the one cow to the leftmost stall and one cow to the rightmost stall, then the distance will be, after sorting the array, will be what? The stalls of n minus 1 if n stalls are there. So in this case n is 5 stalls of n minus 1 minus the distance of minus the position of the first stall. So in our case this will be 9 minus 1, that is 8. So now we can see that our low or the minimum possible answer is just 1, and our high or the maximum possible answer is 8. So we are damn sure that our answer is between 1 and 8 only. So now we can find through binary search. So now 1 plus 8 is 9, and 9 by 2 will be 4. 9 by 2 will be 4. Now we have to check whether this is the possible answer or not, whether 4 is the possible answer or not. So how we can verify that 4 is our possible answer? So first of all, we have to understand how we can verify that 4 is our possible answer or not. So what we can do, that I can just call a function is possible. I can call a function is possible, and there we can pass this mid and all these required variables. And now what I can do, I can keep a count of number of cows I can place, number of cows. So initially we can see that minimum cows we are having k is 2. So let's say initially I am talking about, let's say take one cow, and how many cows can we place? So what we can do, what we can do we can keep track of the last cow where it was placed in the stall. So we can just keep track of the last cow where it was placed. So initially it is 0, and the total number of cows we have placed till now is 1. Now what we can do, so first of all, what was our array? So our array was just this thing. What we can do now, we can, first of all, we will sort the array. Now we can iterate through the stalls and check whether, I mean, check how many cows we can place with keeping distance as 4, keeping our distance limit as 4, because we have to check whether 4 is our possible answer or not. So we have to keep a minimum distance of 4 between cows, and we can just check that how many cows we can place in these stalls such that the minimum distance is 4. So what I can do, I can just use a for loop and iterate here and just check that if the distance of the current stall, if the distance of the current stall, this is the stalls, this is the stalls, so it's understood. So if the distance of stalls, if the current position minus the position where the last cow was placed is is, let's say, it is greater than or equal to mid, greater than or equal to mid, then it means that we can place a cow here, because we will having a minimum distance now. So we can place a cow here. So if we can place a cow there, it means that we should now increase our number of cows, and we can update our last position, last cow position as what? Stalls of I. Now, if we cannot place here, then we can just go for the next stall. That can here I place a cow such that the distance between the last cow and the current last cow position and the current stall is having a minimum distance of mid or not. So after the for loops end, we can just check if the number of cows, if the number of cows is coming, is coming, let's say it is coming uh, less than the given cows. We total have k number of cows. So if we cannot place k cows, so it means that we should return false. It means that we should return false. And if we are able to place greater than or k cows, if we are able to place at least k cows, then we can just return true. All right. So now if I dry run, so my mid is 4. So my mid is 4 now. So here my mid is 4, and now I can iterate and check stalls of I is 1, and number of cow is 1. So stalls minus last is what? Stalls of I is 1. 1 minus 0 is 1. 1 is greater than equal to 4. No, we cannot place a cow here. But think of it. Should we start placing a cow from the first position? So I will start I from 2. Alright. So now I will just start from 2 because I have placed my first cow at the first stall. So I should take here, the last cow was placed at the first uh, stall. So initially I have placed one cow, and the position of that cow is the first stall, and we can see that we have a minimum of 2 cows, so we can do this. Now I will start from I is equals to 2, and I can just check that if the distance between those stalls, like here 2 minus the last stall, that was what? That was 1. It is 2 minus 1 is 1. Is it greater than equal to 4? No, we cannot place a cow. Now moving ahead, 4 minus 1, can I place a cow? No, because it is again not greater than equal to 4. Then 8 minus 1, 8 minus 1, can we place a cow? 8 minus 1 is 7. 7 is greater than equal to 4. Yes, I can place a cow. Now I will increase the number of cows, and I will update the last stall as 8, and now the next cow will come, and I will ask him stall size minus last, that is 9 minus 8. So we cannot place a cow there. Now from this case, keeping a minimum distance of 4, I can just place 2 cows, and we were having exactly 3 cows. So I'm not able to place 3 cows there, so I will return false. So if I will return false, so what should I do? I should decrease the minimum distance. So I will decrease the minimum distance, and I will move to the left. So now I will reduce the mid. So how can I reduce the mid? I can just keep my high as mid minus 1, that is 3, and now my new mid will be 3 plus 1 4, 4 by 1, 4 by 2 is 2. Now again, starting from cow 1 and keeping uh, placing that cow 1 to the first stall, my new mid is 2, and now I will start checking from 2. So 2 minus 1 is what? 1, which is less than 2. 4 minus 1 is 3, which is greater than equal to 2. I can place a cow. Number of cow I can place is 2. And last stall is now 4. at fourth position. Now again 8 minus 4, 8 minus 4, I should clear it, and my last stall is at 4. So now 8 minus 4 is 4. So yes, I can place a cow. So cows I can place is 4, and the last cow is at eighth stall. Now 9 minus 8 is 1. I cannot place. So after keeping a distance of minimum 2, I can place exactly 3 cows. And yes, we have 3 cows. So we can use this arrangement by keeping a minimum distance of 2, and we can store our result initially, let's say, at -1, and now we will update our minimum distance as 2. So now if we found our minimum distance as 2, should we stop here? No, we have to find the maximum possible. So now we can again check for the more possible maximum larger distance. So now I should increase my range, and I should say that my low will be now mid plus 1, that is 3, and my mid will be also now 3, and I will not check for it. So my initially I was placed I placed a cow at first stall. Now if I talk about the next cow, two at next stall, it is 2 minus 1, 1 distance. So my mid was 3. No, I cannot place 4. 4 minus 1 is 3. Yes, I can place a cow. So last cow is at now fourth stall. Now next 8 minus 4. Yes, 4 is greater than equal to 3. Yes, I can place a cow there. And my last uh, stall where cow was placed is now 8. Now 9 minus 8, I cannot place a cow. So this after keeping a minimum distance of 3, I can place 3 cows. So yes, we can return true here, and I will update my result also as 3. Now if I found the answer, I should also find a larger answer. Then again I will uh, write my low as mid plus 1, that is 4. Now we can see that my low should be less than equal to high, but here low is greater than high. So now we will stop and just return result. But we can also see that either we can store our result in a different variable result, or we can see that our high is also representing our answer. So either we store a result variable or we just return high, both will be correct. So now this way our answer is coming 3, and we can see our output was also 3. So this logic is correct now. And now if I just go and implement it, so first of all I will find the stall's size, and then I will define my low. So low I can take 1 for simplicity, and high will be what? So high will be what? If I sort this array, so the maximum possible distance can be stalls of n minus 1 minus stalls of 0. And so for that I have to sort this array also. So I will sort it. Stalls dot begin comma stalls dot end, and yes, we are sorting it, then only we can verify also correctly. We already know. Now just applying binary search, same binary search template, and we can just find mid easily. Low plus high minus low by 2, and now we will check that is this the possible minimum distance. So we can just send mid, we can just also send the array. I am sending the size also and the number of cows, and if it is possible, then why not to go for checking the maximum more possible, more larger distance. So low will be mid plus 1, and if not able to place those number of cows, then go and reduce the minimum distance, and at the end just return the high variable, or we can store it in a resultant variable also. Now if I just write the is possible function as verification. Now here I'm passing mid, this is stalls and the size and the cows, and here I can just keep how many cows I have placed. So initially let's say I have placed a cow at first position, so we can see we have minimum of two stalls and minimum of two cows also, so we are safe here. Stalls of 0, and we can iterate to the array easily. Now we can just check that if the distance from this stall to the last stall where a cow was placed, is it greater than equal to mid, at minimum distance is there, at least mid distance is there, then we can place a cow there, and we will update our last cow stall also. So this will be stalls of I, and we will keep doing this, and we will just check that if a number of cows is coming greater is coming, let's say less than k, we can return false. Else if we are able to place a minimum of k cows, we can return true. So now if I just submit, if I just compile and run this and check whether we have not made any mistake, and let's submit it and check whether we are able to pass all the test cases or not. So we can see that we have solved this problem successfully now. And now if I tell you about the time and space complexity, so we already know that we are using binary search. So log of what? The range is what? High minus low, so log of range. And now in every possible, while in every possible search, we are just verifying also, and this is taking big of n time complexity. So this will be big of log of range into n, plus we are sorting this array also, so an extra n log n time complexity. And space complexity, we can see that we are not taking any extra space, so the space complexity will be big of 1. So I hope you understood. So this was all about this problem. Till then, keep learning and keep upgrading yourself. Thanks for watching. See you in the next video.